All right, here's section 7.3, and our essential question is how can you determine the excluded values in a product or quotient of two rational expressions? Now just remember that product is multiplying and quotient is dividing. So our learning targets for this section are pretty easy. First we're going to simplify rational expressions, then we're going to multiply, and then we're going to divide. But when we do these multiplying and dividing, we're always going to go back and simplify our final answers before we're done. So here's our first core concept, right? So here's my property when I simplify. If I have a times c over b times c, it equals that I have a over b, right? Because I divide out the common factor, because it ends up looking like a times c over b times c. So it's the same thing as a over b times c over c, right? Just when I'm multiplying fractions, I just multiply straight across. And I know that anything divided by itself is 1, so those can cancel out. So I'm left with a over b. Okay, so this is kind of the simplified version, and we can use this in other places, and when we have examples we'll look at. The big thing to note is that neither b nor c can be 0. So anything in the denominator cannot be 0, right? And that goes back to our essential question of excluded values. So anything that turns the denominator to be 0 becomes an excluded value. So let's look at our couple of examples here. So we can use this when we're talking about numbers, right, which we've been doing a lot in math your whole life, is I can divide out the common factor. In this first example, my common factor would be 5, so I end up with 3 over 13. So here in the second example, you'll see I have 4 times the quantity x plus 3 over the quantity x plus 3 times quantity x plus 3, and so I can get rid of that entire x plus 3. The big thing to think about when we're simplifying these rational expressions is if I'm adding or subtracting inside these parentheses, I can't just get rid of the one piece of it. I have to look at the entire thing itself. And this we'll see in the next couple of examples. So I'm asked to simplify this polynomial, this rational expression. So the first thing I want to do is I want to factor. So I know that I can factor this numerator, right? And we're going way back to factoring. So my first term is going to be x for both of them. Then all of my possibilities for a negative 12, right? I can multiply 12 times 1, I can multiply 6 times 2, and I can multiply 4 times 3. And one of these is going to have to be positive, and the other is going to have to be negative, because I'm dealing with a negative 12, and I'm looking for a negative 4. So I know that I'm going to end up with minus 6 plus 2, right? Because if I was to multiply this out, I have x squared minus 6x plus 2x minus 12, and that would simplify to what I have here in my numerator. Okay, so now let's look at the denominator. I know I am also going to have to refactor this out. So this looks like one of my special properties, right? Because I know the square root of the first part, and I know the square root of the second part, and I'm subtracting. This is what we call the difference of two squares. So this ends up being, right, a plus b, right, times then a minus b. If what I have is a squared minus b squared, right? This is the difference of two squares. Some of you may or may not remember this. So this we will use very often here. So make sure you have this written down. So I know my a is going to be x, and I know the square root of 4 is 2. So I'm going to end up with x plus 2 times x minus 2. So now that I have everything factored, I can go ahead and simplify and cancel out what I know I have. So I see I have an x plus 2 in the numerator and an x plus 2 in the denominator. And following along with these properties, I know that anything divided by itself is 1, so I can go ahead and get rid of this x plus 2 in the numerator and the denominator. So I'm left with x minus 6 in the numerator and an x minus 2 in the denominator. So here I'm almost done. But I know that since I'm dealing with a rational expression, I have some values that are excluded. So I know here that x cannot equal 2. Because if x was 2, then this would end up being a 0 in the denominator, and we can't have that. So I know that I have to include this piece, or it doesn't actually work, and I can't use that. So that's the first example. So here are some monitoring progress. I want you to try it, especially number 4. See if you can first factor these and then simplify from there. Because number 1's pretty easy and given to you, so see if you can factor first. So now here's our second part, right? Our second learning target was multiplying rational expressions. So we're going to be multiplying now, right? So before we were simplifying, now we're multiplying. And remember, when we're multiplying fractions, which rational expressions are just fractions, we multiply straight across. So if I have my first rational expression times my second one, it just ends up being AC over BD, right? So here is what I can also see is this example. I'm going to deal with everything individually, right? So 5x squared times 6xy cubed. Well, 5 times 6 is 30. I end up with 3 x's because x squared times x gives me x squared and y cubed. So then I can multiply my denominator. So I'm going to have 2xy squared times 10y, so I end up with 20xy cubed. Now I simplify. Well, I can simplify the numbers first, right? And I know that 30 divided by 20 is the same. It can be simplified to 3 over 2. I have 1x in the denominator and 3 in the numerator, so I'm left with 2 in the numerator, and then my y cubed over y cubed gives me 1. So here's my final answer, right? But I also have to include that x cannot equal 0 and y cannot equal 0 because they are both in the denominator, and if they were 0, then the denominator would be 0, and we just can't have that. So we have to include this piece in order to be mathematically correct. So now let's look at an example, right? So I'm supposed to find the product of these. So I want to go ahead and just multiply straight across. Well, I know that 8 times 7 is 56. X cubed times x to the 4th is x to the 7th. Y times y cubed is y to the 4th. So that's the numerator. Now let's look at the denominator. 2 times 4 is 8. X, there's only one x, so I'm left with that x. And then y squared times y is y cubed. So now I have to simplify. And I want to look at each piece individually. Right, so I know that 56 divided by 8, that one actually divides out evenly. So I can go ahead and cancel that out, and this becomes a 7. I see I have 1x in the denominator, and I have 7 in the numerator, so that leaves me with 6 in the numerator once I've done simplifying and canceling out. I have 3 y's in the denominator and 4 in the numerator, so that leaves me with 1 in the numerator. So here is my final simplified answer once I've multiplied. However, I'm not quite done. I also know that at some point x is in the denominator, so x can't be 0, and I also know that y can't be 0. Because if x was 0 or y was 0, at some point we'd be dividing by 0, and that just can't happen. So I have to include this in my final answer. I can't just leave it. That has to be included. Okay, so that's my product completely simplified. So here's a little bit more complicated one. So this is example number 3. Okay, there are several ways that you can do this, but the easiest one is to do our factoring first. Okay, so I first want to factor everything that I can. So let's look at the numerator of this first term. Right, so I see that I have a 3x in both terms, so I'm going to go ahead and factor that out. So I have a 3x, I end up with 1 minus x. Okay, so that's my factored form of the numerator of the first term. So now I'm going to go ahead and factor the second term. All right, and I know I'm going to end up with x to start with. Well, I know that my possibilities for 5, to multiply to get 5, are 5 and 1. And I know one has to be positive and the other has to be negative, but I'm looking for a positive middle term, so I know that the 5 is going to be positive and the 1 is going to be negative. So there's that factored. So now let's factor the second polynomial, right? So here I've got x and x. So I know to get 20, I can do 20 times 1, I can do 10 times 2, I can do 5 times 4. And I'm looking for an x in the middle, so I know it's going to end up being this one right here. And it's going to be a positive x, so the 5 has to be positive. Okay? And I know that 1's negative because I end up with a negative 20. So now this is going to be over 3x. So now I can go ahead and multiply, right? So when I multiply, I just multiply straight across. So here's what I'm going to do. So before I actually make my life a little more complicated, I'm going to simplify what I can. So here I see I have a 3x in the denominator and a 3x in the numerator. So those can be canceled and simplified. I see I have x plus 5 and x plus 5 here, and those equal 1. So that can be simplified as well. Okay, so I'm left, here's some of the things that I'm left with, right? I'm left with 1 minus x times x minus 4 over x minus 1. So you see that this x minus 1 is different than this 1 minus x. They are very different things, and I cannot simplify them or cancel them out as they're written just like this. So in order for me to simplify this a little bit further, I'm going to have to rewrite this piece of my polynomial, right? And so I know that that is going to be a -1 times x minus 1. I just switched the sign on both of them. So all I've done is I factored out that -1. So I can go ahead and write the rest of what I had, my x minus 4, and it was over x minus 1. Right? So now I see I have this x minus 1 and this x minus 1 that can cancel each other out because they are, together they equal 1. So now I can go ahead and simplify. So I've got this -1 out front, and I'm left with an x minus 4 in the numerator. So I can go ahead and distribute there and end up with -x plus 4. I'm not quite done, so I have to figure out what can my x values, what are my excluded values going to be? So anything that would make my denominator 0 is what I have to exclude. So I see here, with this term, if my x was 0, then I would have a 0 in the denominator. So my x cannot equal 0. I also see over here, if my x was 1, my denominator would be 0. And here, if x was a -5, my denominator would be 0 as well. So these are all of my exclusions. Even though my solution did not have a denominator, I still have to include these exclusions, okay? So my final answer is -x plus 4, but x cannot equal 0, 1, or -5. Okay, so here we're going to be looking at this one. Let's go ahead and rewrite this one. And this is example number 4 that we're looking at. Okay, so the first thing is when I'm multiplying fractions, I always want to just have my fractions, and that's going to be over 1. So again, the first thing is always to factor and simplify as much as I can to start with. So the numerator of my first term, I can't factor. It's as simple as it can be, so I just rewrite it. Here I see something that looks kind of familiar. This is what we call the difference of cubes. Okay, so I know that this can also be written a little bit differently. So in order to simplify my difference of cubes, I can go back and review what this looks like, but it's going to end up being my x minus 3 times x squared plus 3x plus 9, right? And I can see that I'm not really going to have to simplify the numerator over here because that's something that I already have. So what I see when I can simplify that is this entire thing can cancel out with this entire polynomial right there. So what I'm left with is x plus 2 divided by x minus 3. So that's my final simplified answer. So here are some monitoring progress, so try these and see how we do. So now we're going to be dividing. This was our third learning target, was dividing, right? So when I'm dividing by fractions, it's really difficult to divide by fractions. So what I do is I multiply by the reciprocal, right? And this we did a lot with normal just digits and numbers. We're going to do the same thing with our rational expressions. So I leave the first expression alone, and I then multiply and I flip the second expression. Then I can simplify if possible. So let's look at some examples. This is example number 5 right here. So find the quotient, right, which means we're dividing, of this polynomial. So I know I don't like dividing, so I'm going to end up rewriting this. So I've got 7x over 2x minus 10. And then I want to multiply, but I have to flip my fraction. So it's going to be x squared minus 11x plus 30 divided by x squared minus 6x. So first thing I want to do is I want to simplify and factor as much as I can. So my entire first rational term cannot be simplified. I can't factor anything out of either part. So now let's look at the numerator. The numerator I know is going to be able to be factored because it's a trinomial. So I know I'm going to have x, and the way I can get 30, right, is I can do 30 times 1, or I can do 15 times 2, or I can do 5 times 6. And I know that both have to be positive or both have to be negative. And I know that it's going to end up being a -6 and a -5. Like that. Okay, so now let's look at the denominator. Well, I see both terms have an x, so I can go ahead and simplify that out. So I'm left with x minus 6 here. So now let's look and see what I can simplify before I go ahead and multiply. Well, here's an x minus 6 and an x minus 6, and I see I have an x and I have an x. So what am I left with? I'm left with 7 in the numerator and x minus 5 in the numerator, and I'm left in the denominator with 2x minus 10. well, this looks like something else I can simplify. So can't I pull a 2 out from this denominator? So I end up with 7 times x minus 5. And if I factor again 2 out, I end up with x minus 5. Well, here's something else that can be simplified. So my final solution, as I work around into a weird order, ends up being 7 over 2, because everything else could be simplified out. So the big thing then, again, is I have to find anywhere where my denominator would be 0, and those are my excluded values. So my excluded values would be 0, 5, and 6, because those are the different places where I would end up with 0 in the denominator, right? 0, if x was 0 there, it would be 0. If x was 5 here, and if x was 6 here. So my final answer is 7 over 2, but x cannot equal 0, 5, or 6. So here's example number 6, okay? So the first thing I want to do is I want to multiply by the reciprocal, because I don't like dividing by fractions. So I have 6x squared plus x minus 15 divided by 4x squared, and then I multiply by the reciprocal, so I flip this fraction, 3x squared plus 5x, okay? So now that I've done this, I can go ahead and factor. So if I look at the numerator of this first one, I know that this first part is going to throw me off a little bit, but it's going to end up being 3x plus 5 and 2x minus 3. If you want help factoring and going back to review factoring, please come see me, because you're going to be factoring from here on out, and it's very important that you can do it fairly quickly. So we're going to have that divided by 4x squared times, and my numerator is 1, so I see that both of these pieces have an x in them, so I can factor out that x, times 3x plus 5. So now I'm going to go ahead and simplify. I see a 3x plus 5 and a 3x plus 5. And then I can continue and simplify what I have. So now let's go ahead and do this multiplying. So I end up with 2x minus 3. And then I have in my denominator 4x squared times x, which gives me 4x cubed. Okay, so there's my final answer. Except I have to go back and see where I can't have an x value, right? My excluded values. So I know that if I deal with this part right here, x cannot equal negative 5/3. And the easiest way for me to figure that out is I can set it equal to 0. So 3x squared plus 5x equals 0. And then from here, I'm just going to solve for x, and here's what I'm going to end up getting. So that's the easiest way to find my excluded values. Just set the denominator equal to 0, and those would be our excluded values. Okay, so now we're going to be looking at our real life problem. So the total annual amount, I, in millions of dollars of personal income earned by Alabama, and its annual population, P, is in millions, can be modeled by these two different equations, right? Where T represents the year, with T equals 1 is 2001. Find a model for the annual per capita income. Per capita means per person. So that means I'm going to divide by my population. So then I have to assume T is greater than 0, and then I have to figure out an estimate in 2010. So the first thing I want to do is I want to divide my I by P. So instead of dividing, right, I'm going to multiply by my reciprocal. So I end up multiplying and I flip my fraction, okay, because I don't like dividing by fractions. So then I go ahead and I multiply just straight across. I leave my two things in the denominator as they're written before I do anything else. So here's my model, right? And I don't have to simplify it any further than this because we're dealing with funky numbers, so I'm just going to leave it like this. So now the second part is I'm going to estimate in 2010. So T needs to be 10 in the model. So anywhere I see a T, I substitute a 10, and then I go ahead and I calculate, using a calculator, that the estimated was 34,707. Okay, so I could then rewrite that using words, explain my answer. So in 2010, the per capita income in Alabama was approximately, or about, $34,707. So the first thing I had to do was write my model, and then I had to figure out when T was 10, what did I get? So those were our big two things. Not too bad. So now here is your monitoring progress. So I want you to go ahead and try these and see how well you do. So let's look back at our learning targets and see if we were able to meet those. So our first one was to simplify rational expressions. So we did that several times, and the biggest thing when we simplify is factoring. So if you need help factoring, please come see me. Our second learning target was multiplying rational expressions, and our third was dividing. And remember that when we're dividing, we're really going to end up being multiplying by the reciprocal. So really these two go hand in hand together. So now that we've worked on these learning targets, go ahead and work on that homework for 7.3.